Hi, everyone. Welcome to May 15th, Thursday LEAP Lecture in Climate Data Science. It is my pleasure to welcome today Nguessan Cícer Kouadio from Côte d'Ivoire. He has a background in geophysics, and he's currently pursuing a master's degree in climate change and marine sciences at the Universidade Técnica do Atlântico in Cape Verde under the WASCAL program. And his research focuses on the interaction of ocean currents with wastewater plumes and its physical dispersal around São Vicente Island. He's committed to applying data science and machine learning techniques to solve global problems with respect to climate change and sustainability. And Cícer's recent research, as part of the Climate Match Academy's Climate Impact Scholars Program, spans leveraging deep learning models to predict rice yields in India and explores how climate variability influences agricultural productivity. Cícer is also a passionate climate activist. He has won multiple awards for his environmental initiatives, including being a finalist in the 2024 Project Green Challenge. And I believe he received that in California. And then finally, he's a passionate educator, community leader who believes in empowering the next generation with innovative solutions to global climate issues. So, Cícer, thank you so much for joining us today, and the floor is yours.
Okay, thank you so much. So, good morning, good afternoon, and good evening, everybody from where you are. I am very pleased to present today on empowering climate research with LEAP Pangeo, insight from crop yield prediction and possibilities of improvement. So this is the outline of my presentation. I will first start by giving some information about myself, a brief introduction. Then I will move to overview of the research project I was involved, and I use the LEAP Pangeo computer resources. So on the third point, I will highlight the role of Pangeo computing cloud in our research and finish by giving feedback and suggestion from improvement. So about me, basically I'm from Côte d'Ivoire. Yes. Okay,
Hi.
so I'm basically from Côte d'Ivoire, here located in West Africa. So I studied Bachelor in Earth Science in Abidjan at Félix Houphouët-Boigny University, and also did a master in master in applied geophysics. Then this was in 2019 until 2023. Then
Cícer, are you having some technical difficulties? We
yeah,
don't hear your voice here.
yeah, I have some. Okay, so I think, yeah, it's okay. So then I moved to Cape Verde for the WASCAL program. So specifically in Mindelo here, Mindelo in Cabo Verde, at São Vicente Island, where I am doing my current master program in climate change and marine sciences at Technical Atlantic University since 2024. So for this master, I am working on wastewater dispersal into the ocean using Lagrange tracking particles around the São Vicente Island. So currently I am in Germany for 3 months research stay, where I'm staying in Kiel, specifically at Guiomar. So let's start with the overview of the research project. So basically this research was developed after the climate match course on computational tools for climate science, where I collaborated with some people from India, from Cameroon, and also from Brazil. So the title of our project is Hybrid Deep Learning Model CCN Convolutional Neural Network and Gated Recurrent Unit for Crop Yield Prediction under Climate Impact. a case study of India. So basically, we developed a deep learning model to predict crop yields, specifically for rice in India. And this research was part of the Impact Scholar program, which was implemented by Climate Match Academic, to whom we address our profound gratitude for their support and for their sponsor. So the goals of the project was to first to develop a deep learning model considering ocean indexes, climate variables in India's region, and predicted rice crops yield from AgMIP. The second goal was to evaluate the prediction rice using the CMIP6 scenario and possible impact over India, and under different scenario SSP 245 and SSP 585. So for the method, basically we extracted the data from the Norwegian Earth System model and also from the MIROP6, all incorporated into the CMIP6 model. And from the CMIP6 model, we extracted the ocean indexes, which are represented by the sea surface temperature. We use it to compute to get the DMI and also the ENSO. And then for the climate variables, we looked at the precipitation rate, the relative humidity, the soil moisture, and the air temperature. So for the data set, for the crop yield of rice, we use the data from the EPIC Boku. This is basically environmental policymaker integrated models. The LPG gas and the LPGML are basically representing the dynamic vegetation, and the PEPIC is basically a kind of EPIC also that was developed by the Chinese. And for the temporal resolution, this data came with a yearly resolution for as temporal resolution and a year of record from 1901 until 2012. So basically, the data from the CMIP6 was monthly data. So before incorporating them into the models, we had to put them at the same scale. So this, the monthly data from the CMIP6, we also average it on yearly basis before incorporated into the model, because this one is yearly data. So this slide shows the deep learning architecture. So as you can see, we have two main sides, like combination. So on the left side, you can see the climate input. Climate input representing the climate variables such as soil moisture, temperature. And on the right side, you can see ocean indexes representing ENSO and DMI. So for the CNN box, here we just we formatted the climate data into 2D maps, and also for the GRU, we use for the GRU, we just input the data that are basically time series dependency, such as the ENSO over time and also the DMI over time. So this GRU is basically from RNN, the recurrent neural network, which is basically good at capturing the time series dependency in a data set. So coming back to the CNN, these 2D maps, after we applied four convolutional layers with different depth of filters that you can see here, increasing from 32, 64, 128, and 128. So, and all of them with a kernel size of 3 by 3. So then what we did next, we combined the two. So this is the CNN was used to access the spatial the data that depend on the spatial, and also the GRU was used for the data that can access the time series dependency. So because we wanted to capture these two features, the spatial features and also the temporal feature. So that's why we try to combine the two algorithms to get at the same time feature temporal and spatial. So then we condense the two into one dense layer of 1025 neurons using ReLU activation. Then after that, we had our output that I will show later. So for the training details, you can see we split the data with 80% for the training, 10% for the validation, and 10% for the testing. Okay, so this is the performance metric. As you can see here, the mean square metric, mean square, you can see 0.307. And then we also have the MAE of 0.01729 for validation, and also the square R score, the score of 0.9, which is very good. So as you can see on this, the plot on the top right here, the training and validation loss over epoch, you can see that we have a decrease on the training and also the validation loss, the training loss and the training loss and the validation loss. We had a decrease, and then we have a convergence. So this means that we don't have so much overfitting in the performance of the models. So which shows that the models has a good performance. So then here you can see on this map from left to the right, you can see here the mean of the model prediction. This is for the rice per kilogram per hectare and per year. From B, you can see the mean of the test observed data. And finally, at the right side, you can see the percentage difference. So this is basically the difference between the prediction and the observed. So which is, so for the final ones, you can see that here we have a light blue, most of the area, light blue and light red, which shows good performance, apart from some part of the Western Indian that we have some losses. Okay. Okay, then we have a result here. So as you can see here, the first alignment, the first triplet on the top, there shows the results under the SSP 585, and the three other plots below shows the result over SSP 245. So as main message here, we can see that in the difference here, the plot on the right side, you can see that we have a decline. Like we have a high decline in the rice production all over the Indian region. And for the scenario SSP 245 also we have a decline, but the decline under the scenario 585 is more pronounced here, as you can see. So which means that under high emission of SSP 585, we will have a decline in rice production in over India. So this is the time series also that we extracted from the model. So as you can see again, we have a decline in rice production, and it is more pronounced under the SSV scenario SSP585. Then the key insight from this work. So as first insight, we can see that the model overestimated from 1 to 3%, which is good. And also a second main insight, we can see that the rise are projected to decline significantly under climate change, especially under the high emission of SSP 585 scenario. And there is also another insight, which is the rice yield is highly sensitive to ocean climate interaction, and soil moisture and ENSO indices are better predictor than rainfall alone. So I couldn't show all of the details of our work in the presentation, but I will give you I can give you the link after if you want to read the full work to get some more information. So, but what we observe is that under the soil moisture and ENSO, they were highly correlated than the rainfall. So, which means that if we wanted to use the rainfall alone as our predictor, maybe we will get something which is not so realistic. So that's why we noticed that, the soil moisture and the ENSO were the better predictors. Okay, now I will move to this part, which is the role of Pangeo computing cloud in our research, because it has played a crucial role during this work. So basically what we needed access to terabyte of CMIP6 because it is a very large data set that will be very difficult to download if you want to download. Yeah, very, very large. We also needed a scalable computing environment for pre-processing data, merging, and generating model input. We also needed integration with external, such as AgMIP and DVI for the models. And what we got, so basically we were provided the Jupyter Hub from Pangeo, so which had a flexible and multiple computer environment. And as you can see on this image, they were from 8 to 32 GB of RAM memory. So we were able to choose whether you want to use 8 GB, 16 or 32. So it means that it is like it depends. If you have so many large data set, you can go for 32. And this was a very good point of using it. We also had another option which we were able to decide if we want to use the basic Pangeo notebook or the PyTorch for ML notebook, the Pangeo TensorFlow ML, and we were free to choose. And this was also something very good. Then another thing that was good is the cloud-based access to climate data sets such as CMIP6. As I said, it is a very large data set, and if you want to download, it will be time consuming, and maybe you have to have a strong machine to do so. So basically what we did, we just loaded the CMIP6 from the Jupyter Hub provided by Pangeo. So we first installed some packages that were required, such as the intake ESM that we first installed, and then we loaded the data through the HTTP. So after that, after loading the data, we were able now to select whether we want which variable we want and use its reference to get it. So as you can see on the screen, yeah, we have the source. We use the source ID, the experiment, variable ID, table ID, number, and yeah, for the variable, if you want to change the temperature in the CMIP6 is PR. If you want to maybe to take the SST, you will just change here by TOS and then you load it, you will get your data. And with that, we didn't need like a high computing resources or download data locally, and like everything was running into a browser, and that was very good. So specific tasks, then when we were able to load the data from CMIP6 and so on, we started with visualization, like spatial visualization and also temporal analysis and so on. So we were also able to merge the data easily, and everything was working very pretty good before the development of the model. Okay, so for the feedback and suggestion, so I will first start by what worked well in the process or during our project. So we can see that we have an easy access to CMIP6 via intake and ESM. So packages, we didn't need to download the data. Yeah. So we were also able to clean and also familiarize with the Jupyter notebook interface for those who were not familiar with it before. It was flexible with memory options. We were able to choose depending on the weight of our data. It was accessible also for researchers in low income setting. So it means that not everybody can get access to it. So if we got access and it was free. That was very good. And some challenges that we faced. So we faced actually some challenges that I didn't put here because we didn't plan to do this presentation before. So there are some challenges that we didn't put it here. So, but the main ones are the complex packages dependencies, because when we tried before loading the CMIP6, it was a bit difficult. Some version of NewPine with X-array were mixing here. So we were just trying to change and finally we got the right ones. So after also another challenge is the requirement of understanding of technical terms. Maybe for instance, you want to load the CMIP6 model into the GPT Hub. Like there were no tutorials, so you have to know what you want and how to do it. Because if you were very new, it will be like almost impossible to do so. So this was also one challenge. And the data from AgMIP was not available on the computer, on the Jupyter Hub also. So we just upload this one manually. So based on that, some suggestion is to include a pre-installed climate modeling packages, maybe to avoid the package dependency, like the packages conflict with the different version. If we had maybe a pre-installed packages that could work fine, I think this will help us in saving time. So if they can improve this part, it will be much better. And then if another improvement will be also adding the tutorial for loading large climate data set. As I said, for CMIP6, for instance, you have to be familiar with the ID, with everything before you can be able to load it. And also include some link for large data set. For instance, AgMIP, we couldn't load this one directly. So if maybe they can put some link, you can click it and go directly to download. This will also attract more people to use this computing resource. So now for the next step, how I plan to use the computing resources. As I said, it is very good, it is helpful. So I plan to use it further. So first of all, I want to maybe to use it to scale my racial modeling across other regions such as West Africa, because this one was in India. We basically did it in India because in our team, there were many people from India, so we decided to first start in India, and then you can apply it everywhere we want. So I plan to also apply it to my regions in West Africa. Also use the platform for future climate model analysis and publication workflows. Leverage it for future PhD level in ML or in climate study. So for LEAP to get broader impacts, these are some opportunities for growth that I try to highlight. The first one is to extending the access to more researcher, maybe by promoting the LEAP Pangeo to early career researcher in the global south, because I think where this is not so known is the global south, such as maybe West Africa. Yeah, it is actually not known. I don't know why. And also, if this will be difficult, but if it will be possible to translate the onboarding materials into French or any other language for inclusivity, that could be also very good. And partnership, another good point is to also partner, as I said, in the global south. I'm not sure if this is well known, but they can partner with institutions there, maybe in Cote d'Ivoire, in Nigeria, Senegal, with institutions like Pan-African AI, Climate Lab, and so on. And further, they can extend the collaboration, like the collaboration they have with Climate Match Academy, which is based on training, access plus mentorship. So if they can extend this one also to the global south or maybe to Asia or any other place, will be much better. Then the summary. So basically the research integrated climate variables such as temperature, rainfall, humidity, and the ocean indices such as ENSO and IOD. The research also achieved high accuracy, mean absolute error, and identify key drivers like soil moisture. The computing enabled the cloud-based access to large datasets such as CMIP6, facilitated research without local, like high computing or maybe downloading data this large dataset. So some recommendations are maybe the platform is powerful, so I highly recommend it. So if maybe they can improve it, maybe the need to easier packages or environment management, also suggest a clearer onboarding materials, more beginner tutorials and regional language. And also I recommend it maybe to expand access via institutional partnership training program across West Africa and the global south. Okay, this is my final thought. So basically, LEAP Pangeo resources empowering our research with improved support and outreach. It can empower thousands of scientists worldwide. And I also want to thank you so much for this opportunity, like to share my research, to give my feedback, and so thank you so much. And thank you also all those people who joined the presentation. Thank you.
Sarah, thank you so much. If
So
there are any questions, Cesar, do you have a few minutes to take questions from
yeah,
the audience? Okay. I think
okay,
we have a question in the room here, and for
mm,
our Zoom participants,
okay,
you can feel free to type your question into the chat, or when this first question and answer is completed, you can just unmute yourself and ask into the room.
Hi, thank you for your presentation. Very nice work. And my question is about the first part of your presentation, which is related to the your results regarding the machine learning model used for extrapolating crop yields on future projection scenarios.
yeah.
And yeah, my question is that as far as I understood, you are using your machine learning model for extrapolating, right?
Mm.
unseen data, and this data comes from CMIP6 simulations. But I'm a bit concerned regarding the results, because you don't show any uncertainty quantification, and like and you know that the climate is we don't know how the climate will be in 100 years, for example, and that's why we have different climate model simulations.
Yeah.
And you use just one simulation, but I don't see the the quantification of the uncertainty. So that's my question.
Okay, so yeah, thank you for your question. This is a great question. So we thought about extending to maybe to find the uncertainty, but as the result here, you can see here like the score were very high, and also the losses were like very minimized. So that's why for now we didn't go for the uncertainty, because we already have high performance of the models. But I think this is a good point, and maybe for the future work of the project we can look at that. And we even plan that this uncertainty, one of our teammates also highlighted this point, and we have planned to go for it for the next step.
Okay, thank you. So I see that your results on the training set are quite impressive.
Yeah.
But you are trying to extrapolate to unseen data, and so according to the scenarios that you are using, we expected the distribution of such data is slightly different from the one you used for training, right? So that's why these results that are quite impressive on training data does not necessarily confirm or you know transfer on unseen projection scenarios, right? So that's why maybe quantifying the uncertainty and using also emulators of other CMIP6 models can use to better assess your results on future projections.
Yeah, I think one of our plan is also like a generalization, because as I said, I will change the region, maybe apply it to other region, and then we will be able to see and quantify like the performance.
Anything online? Are there any questions online? In the meantime, I can ask mine. My name
Yeah.
is Geneva. I'm a LEAP staff here,
Okay.
working on knowledge transfer. And this is really exciting to see the use and application of LEAP Pangeo research. And my question is actually, I really loved some of the follow-up steps that you mentioned with regards to collaborating with different folks, especially in West Africa. And I was curious if you are working with Africa Rice, because I know the headquarters is in Cote d'Ivoire. And I was just thinking this could be really interesting as you wrap up this to maybe take it to Africa Rice and some of their CG affiliates like the International Rice Research Institute, which I know is based in the Philippines. But I think both of those organizations, fantastic applied, ag research organizations for climate, would be really interested in your results and would really like to see how LEAP Pangeo can be used for them.
Okay, yeah, I think that's good.
Yeah. Do you work with Africa Rice at all?
No, not really.
Okay.
The institution from West Africa, which I am part is WASCAL.
Uh-huh. Yeah,
Yeah.
awesome.
Yeah, it's WASCAL basically for West Africa mainly. So I don't really know. I don't know much about African race.
Oh, good. Well, maybe an organization to look into. I'm sure that there's a lot of overlap. It would be perhaps great to know.
Yeah. Okay. Any
Oh,
other
hi,
question?
I have one. Oh, was someone asking
Yeah.
a question?
Yeah. Yeah. Oh, you can. Yeah.
Sorry. This is Molly Lopez. I work at LEAP also, and I just really appreciate the feedback and suggestions that you included. They're so clear, and it's great to hear how what supports are working well and what supports could be built. further. And I was wondering, as somebody that has used this platform, what do you have any suggestions about, like, the most effective training platform, or like, would live virtual trainings be helpful? Would recordings be helpful? Written documentation, or any communications that are particularly useful, like Slack channels? What have you found helpful, and what do you think could be even more helpful?
Yeah, I think you can if it is possible, maybe to add some tutorials in the Jupyter Hub, like the same way Climate Match Academy did. This was quite impressive, and like it was like very good in saving time, because you go and you see if you need any package, you will see the packages, they are aligned for a specific task. So you see, if I want to do this, this is what those packages I can use. If I want to do that, I can use those packages. So it was quite easy, and there were some videos in the tutorials, some videos, some tests you can read. You can also watch video, and then you do it yourself. So if this can be also included in the Jupyter Hub, this could be very helpful and attract more people. I
Great,
think,
thank you.
yeah, it will be a kind of training at the same time, because you go and once you load in, you will see the tutorials. If I want to do this, I can follow that, I can follow, and it will be easier.
Thank you. That's really helpful.
Yeah.
Are there any other questions? Anybody on Zoom or anyone in the room? Okay, I want to thank you again so much for a wonderful presentation. And if everyone could stay on for just a few minutes, I want to invite Viviana to say a few words about Climate Match Academy.
Yes. Hi, everyone. Thank you so much for this opportunity. I'm Viviana. I'm the project manager of the Impact Scholars. Then actually hosted this project, as it says, and is like one of our scholars. So yeah, very excited actually to like hear this talk. For me, it's the second time, because we hosted seminar presentations. And so I would love to share some of the opportunities that we currently have at Climate Match for becoming a mentor. So we do have in July, we are starting our courses, and we closed now the enrollment for students. But we are looking for project mentors. So basically, during our July courses, in particular, I'm talking about Climate Match. So for 2 weeks, our students will go through a theory, but also practice in the computational tools for climate science. And we are looking for project mentors that during these 2 weeks can have the opportunity of becoming project mentors for just like the commitment is 30 minutes for approximately 3 times. So overall, it would be like 1.5 hours. And we currently have this as an open opportunity, and I can share with you the link for this in the chat, so you can read more about becoming a mentor for our courses. Yes. So this is one. And the second thing that I would absolutely like to share is actually related to the Impact Scholars. So the basically with the Impact Scholars, we are expanding our courses, meaning that, as I said before, our students during our July courses have the options to go through theory, but also projects. And during the 2 weeks of the course, they do develop a small project. And with the Impact Scholars, we gave them the options to carry on the project that they started for 6 months. And during this 6 months, they developed the research project under the guidance of a mentor. At the end of the 6 months, our scholars will produce a micro-publication that do get published on Zenodo. If you go currently on Zenodo and Science Match, you will already see the previous 2023 publications from computational tools in climate science from the Impact Scholars, and we are about to actually publish the one from last year cohort. So yeah, during this 6 months, scholars go through their research under the supervision of a mentor, and the mentor commitment in this case is for the entire, for the full duration of the project that will start from November 3rd up to May 2026. And the commitment for mentors is of 10 hours a month. There is also the option for of getting compensated for it. And I will share a link for this as well. So this link that I shared here is basically related to the website of the Impact Scholars. However, like this is mainly related to last year cohort. We are still like modifying the website for next year for 2025 cohort that again we will start on November 3rd. But we will open mentors application in August. And like if you like wanna stay updated about everything that we are doing and when we open applications, I will absolutely and strongly suggest to follow us on social media. So you can either follow ClimateMatch or NeuroMatch, and we will share all the information there. And again, I would like absolutely thank LEAP for the opportunity they gave to our scholars today, and also because you absolutely supported all our ClimateMatch scholars during the 6 months. And yeah, looking forward for future collaborations. Thank you.
Great. Thank you. Thank you so much, Viviana and Nikesan. Thank you for the wonderful presentation. And we at LEAP are also looking forward to future collaborations with ClimateMatch. Okay. Any other questions? Okay. Thank you so much, everybody.
Thank you. Bye.